So it's a super cold night here in Western Pennsylvania. I've kind of taken a break from the framing for a couple days because my friends needed to use my garage to work on their Jeep. So I didn't get any lumber, but I'm gonna be doing the electrical work here pretty soon after I get these beams built in the next video. And so I thought I'd take this opportunity just to kind of explain how the wiring's gonna go, the wiring process, how three-way switches work, how to wire up outlets, which wire to use, which breakers to use, and just kind of give an overview of what I'm gonna be doing, which will also help those of you who wanna do wiring at home. It's basically exactly the same principle they would use to wire light in a bedroom or down in basement projects or wherever you need to do wiring. So hopefully this helps you out. And as with all my videos, this is kind of a do this at your own risk. This kind of work is dangerous. I've mentioned it with the nail guns and with the table saw, things like that. One accident can certainly change your life, but it's nothing that is to be afraid of as long as you just kind of respect the tools and certainly respect electricity. I know that this stuff really isn't that difficult to learn. A lot of people are just nervous because electricity is electricity, and they always hear about people getting shocked and whatnot. But of course, do this at your own risk. But this is really simple things that pretty much anybody can figure out. I'm sure you're familiar with electricity in that if you have a circuit, it has to be complete. And current is nothing more than a flow of electrons around a circuit. And all these electrons do are go around the circuit, but in order for them to flow, you have to have a closed loop. And that's one of the basic principles of electricity. And what I use when I wire is this Romex. A lot of electricians, they'll use the individual strands, but I like the Romex because it comes with 3 wires inside. So I don't know if you can see that, but inside here there's 3 wires in this jacket. And what's nice about it is it's basically 1 wire that can complete your loop. And what I mean by that is, let's take our panel box, or in my case out here, it's gonna be a sub panel. And I'm gonna take power from the box to something like, say, a switch. Then maybe I'll come over to a light, and then I'll continue back. And in order for this circuit to be complete, the power has to leave the panel box and get back to the panel box. So with this Romex, it's really nice because let's get rid of this copper wire if I can grab it. It's freezing cold, so I have my gloves on. So now let's look at this from the perspective of the Romex. So we have our panel box. Oops, a little dyslexic today. The power leaves. The power, and when I say power, it's, they might say a line's hot or where the electricity is coming from. So the power is coming from the panel box through the black wire, and say this is where our switch will be. Say we'll have another black wire that'll come over and hit our light. And then this is what completes our circuit, is now it'll travel down this white wire and go back to one of the bus bars in the panel box. So the copper wire is your ground wire, and it acts similar to the neutral wire. It provides another avenue for the electricity to get back to the panel box and complete the circuit. In outlets, it's a safety thing. Instead of you becoming the short circuit and going from the hot to yourself and hurting yourself, it'll actually provide another avenue to get the electricity back. And since this copper wire is more conductive than you are, it'll make it back to the panel box and down to the ground safely. Okay, so I drew out some circuits here that are gonna represent the circuits that I'm gonna use, the smaller circuits I'm gonna use in this building. There's a few more, and a few people have reached out to me, asking me some questions on YouTube, and I'll create another video that gets a little bit more involved. But the one thing that I wanna preface is I I'm not one of these guys that take shortcuts with a wire. There's different ways to wire these circuits to save some wire. And for me, I just like it to work 110% of the time. And so I absolutely won't, use if you look up some of these circuits online, people actually take the neutral wire and they'll make it a hot to get it to run back and run a switch or something like that. I don't do stuff like that. I'd rather spend the extra couple dollars and just make sure it's gonna work regardless. But I've come into rewire houses before and do different things, and you have to sit here and play these little games and figure out where the wires went in these circuits, because they decided to use the neutral as a hot wire to go back to lights and different things like that. So just for ease of the next person, I certainly don't like to make things more complicated than they have to be. So we'll start out with the little panel box that I made here. And these breakers, I put out a couple breakers here, and they're all a little bit different. And you can tell they're always marked what the amperage is. The voltage in these circuits is always 120 volts, but the amperage is different, and that's what you want to pay attention to. The white Romex is 14 gauge, 15 amp wire, and the yellow Romex is 12 gauge, 20 amp wire. And so whenever you're running these circuits, you want to make sure that you pair up the proper breaker size with the proper wire. You can always say put a larger wire on a smaller breaker, and that's not a big deal. But you never want to go the other way and say put that 14 gauge 15 amp wire on a 20 amp breaker, then you could potentially cause a fire. One thing that you do want to pay attention to with the breakers, a lot of them are, they're all kind of specific to certain boxes. And so you want to make sure that you use the correct breaker or the compatible breaker for the type of box you have. So if you have a General Electric box, you may not be able to use a Murray breaker in there. And you can see some of the connections that they'll make inside the box are a little bit different. They won't always hook up the same way. And so you definitely, when you go to, if you want to run an extra circuit for whatever you're doing in a garage or basement or whatever, you want to make sure that you select a compatible breaker to hook up the circuit in your panel box. Okay, so here's my little panel box drawn out. I'm gonna use a 20 amp breaker. And you'll see that just like in my last video, I have my little bus bars here on the side. So for my sub panel, I had to separate the neutrals and the hots. So I have the white wire, the neutral going to one bus, and the ground going to the other bus. I have my breaker in the middle, 20 amp breaker with my 12-2 wire and 12 gauge wire and my 20 amp wire. So you'll notice I wrote 12-2 here, and you'll notice I have 14-2 down by this white wire. And it's a little difficult to understand at first. You'll notice that there's 3 wires in this yellow Romex. So why would we call it a 12-2? Well, I don't know, that people that manufacture this or whatever, they, electricians or whoever came up with this, I guess they're only considering the 2 wires that are used to, like the 2 main wires to transport to conduct the electricity. And so you don't count the neutral wire, or you don't count the ground wire. And so this is a 12-2 wire because it's 12 gauge wire and there's 2 wires inside. If we come over to this little wire, you notice it's white, so it's 14 gauge, 15 amp wire. But you notice that it has another red wire. It has a red wire, so there's a white, red, and a black wire. So this is going to be called 14-3 wire. 3 wires not counting the ground. And that's very important when we get to this circuit, which is going to be a 3-way switch. Okay, let's start with the typical outlet. Wiring a typical outlet in your home. So this is rated for 20 amp circuit. So like I said before, we have our panel box or sub panel hooked up. So let's discuss what's actually going on to hook this up. We hooked up the black to the breaker, and then we hooked up our other 2 wires to the buses. Then our yellow wire comes along, and I use blue instead of the white wire, just because obviously there's no way to draw white on white. So I have the white wire that I hook up to the silver screws. I have the copper wire, which is hooked up to the ground screw, and I have the hot, which is connected to the copper screws. So this is very standard. If somebody hooked this up backwards, it's not a huge deal. AC power is pretty forgiving. There's a whole theory behind it. So if you connect them backwards, just connect them back the right way. I don't really want to get into the theory on how all this stuff works in this video. So whenever you turn the breaker on, it's going to make the circuit hot, which means this black wire is going to have power to it. It's going to have power clear up to this screw and into the terminals here. And as soon as you plug something in here, you're going to complete the circuit. So if you plug in a lamp and turn the lamp on, your power is going to flow through the black wire, and it's going to go through the lamp, come back to the neutral, and then head back out all the way back to your panel. Okay, that was for a single outlet. For 2 outlets, it's not a big deal. Same process. Come over to your first outlet. You're going to hook up your neutral to the silver screw, and you're going to hook up the black wire to a copper screw. And then with your other screws, kind of follow me on this, your other neutral is going to come up and hook up to the silver screw. Your other black wire is going to hook up to the top. I would recommend trying to stay consistent. Make sure that if you hook this black wire up to the top, hook up that other neutral to the top of the silver screw. And then this wire would go to the bottom, this other screw would go to the bottom. Just try to stay consistent when you do electricity and try to keep things neat so it's easy to follow. Here you're going to have to actually wire nut these copper wires together, because as you'll see when I go to actually wire the building, you'll notice that there'll be a wire off from this copper wire coming off, this will be wire nutted, and then this ground will come in, then this ground from this other wire will come in. It's not good practice to put 2 wires on 1 screw, and so what you do is you kind of make a pigtail here and connect them all together. And then heading down the circuit back to the last circuit, same principle as before. Just hook it up and just terminate the circuit at the end. Okay, now we're going to hook up a light. And you guessed it, we're going to use a 15 amp circuit with our 14 gauge wire. Same principle as before. We're going to hook up a ground to a bus, neutral to a bus, and we're going to hook up the black to the breaker. And we're going to come over to the switch. Let's start with a ground this time. Remember we had on the last circuit, we had a ground wire and a ground wire from 2 different wires. What we're going to do is the same thing. We're going to create a little pigtail and bring the 2 grounds over, and we're going to wire nut them together. So we've stayed safe, making sure that there's not 2 wires on 1 screw. Then we're going to hook up our neutral wires. And the reason is because the neutral wires aren't going to break the circuit. It's the hot black wires that are going to break the circuit. So as we were talking before, you have a circuit, and as long as the electrons can flow around, or as long as the power can flow around in a circle, you're good. What the switch does is break it at a certain point, so the circuit's broken and your light turns off. And so what we'll do is we'll hook the 1 black wire up to the first screw, and then we'll bring the other black wire over to the bottom screw. It really doesn't matter which side you want to put these on, because all you're doing is breaking the circuit. Nothing's really specific here. And so what's happening is when you flip this breaker on, we'll go ahead and turn our breaker on just for good practice. We turned our breaker on. Now all of a sudden the circuit's hot. So now electrons are flowing, or our power is flowing over to the first hot screw. But you'll see that our switch is off. So these contacts aren't being made. But now if we turn our switch on, now the electricity is flowing through, contacts made through the switch, and it goes over to the black wire, comes over to your light fixture, and then this light turns on, and since this is on and completing a circuit, the power is also, electrons are also flowing back through to your panel box, completing the circuit. Even though I have this little old-timer light, this works with pretty much any light that you have, and a lot of lights I've seen they don't really have places to hook up the ground, so don't completely panic. If there isn't a place to hook up the ground, you just take that ground wire and push it way up in the box out of the way. And if you have any questions, obviously contact a real electrician. I just play an electrician on YouTube. I know what I'm doing, but I can't answer all the questions to every situation. As soon as the circuit is made here, you can put as many lights on here as you want if these are wired correctly, which I'll show you how to do that when I'm actually wiring things up. And then as you wire these things up, the electricity will flow through multiple lights and then end up completing the circuit. So really, there's really nothing to be overwhelmed about. Hooking these circuits up is actually pretty simple. So I can tell you people are pretty smart just by looking at you. And so we're gonna move on to a little bit more advanced circuit, and this is a three-way circuit. And what this allows you to do is control a light from two different switches. And these are used for stairways or in large rooms, or if you have two doorways. The reason I'm using them is because I have two doors. So what I want to be able to do is walk in this door, turn on the lights, grab a tool, do whatever I'm going to do in here, and then be lazy and not walk out that door. I want to walk out the back door. And so what I can do is as I leave, I flip the switch off over there and it still turns off all my lights. So same principle here. We have our panel box, and we have our neutral and our ground hooked up to our bus bars, and we have our breaker. And so same thing, the 14 gauge wire, the 14-2 wire is hooked up, and it's pretty simple at first. It comes over and it's connected just like we connected our other switch. We came up here, we hit a screw, and we hooked up our ground, and then we hooked up our neutral. This is where this gets a little bit trickier with a three-way switch. Your power comes in on the black screw. And the way these switches work is as you flip the switch up or down, right now, you have it flipped down, so say like this screw would connect to this terminal. Let's say we flip it up. This screw now conducts to this terminal. And why that's important is, let's say that the hot power is coming through, or the power is coming up to this screw. Then let's say that it conducts across from this screw to this screw, and then it goes into this red wire. And this red wire and this black wire are called traveler wires. So let's say that it goes across to this screw. Now we follow the red across. We come up here. Now look, our switch is down. So let's say that this black screw is connected to this screw. Well, now there's no way to conduct across to complete the circuit for the light. And this is how three-way switches work. Right now, you can have power up to this switch because somewhere power is coming through up to this switch. And this is where it's going to break. So say that I flip this switch up. Now let's follow the path of the power. I'm getting really bad shadows here. So now we have the black wire coming over to the black screw, comes across to the red, to this screw here, connected to the red wire, comes across, hits the red wire. Now it comes over to this terminal here, the screw here. Now it conducts across, and look what it does. It hits our light, power hits our light, goes back through the neutral wire, it goes back around, back to our panel box. We've completed a circuit. Now let's flip this switch off. Let's see what it does now. Black wire comes across, hits this screw here, comes to this screw. Now we follow the black wire around, except for this conducted this way without the switch being up. Now we have no conduction through this screw to this screw, which means the power
won't make it to the light. And that's how three-way circuits work, is these two switches kind of work together to break the circuit through these traveler wires. And that's why you need a 14-3 wire, because you need this extra wire for traveler wires. So when you wire this circuit, you're going to wire up the switch just like normal. Just go up to your black screw wherever the power is coming in at. And then you're going to take the black wire and the red wire and hook them up to whatever terminal, whatever screw you want. Doesn't even matter. But when you come over to the other side, be consistent. If you hook the red screw up, or if you hook the red wire up to the screw on the right, do the same thing here and hook the red wire up to the screw on the right. And same thing with the black. You just want to be consistent. So these circuits are pretty basic throughout your house. There's different outlets and stuff you can use with the GFCIs, and I'll wire those in later and explain a little bit more about what they are. But I just wanted to do a video on some of the basic wiring. I have a bunch of friends and stuff that, you know, I always do their wiring, or I'm trying to teach them how to do wiring, and they're interested in learning, but they just need some way to get started. So I hope this helped you out. I really enjoy teaching people how to do things. I've got comments that they're like, oh, you know, you do a good job explaining stuff. I try. I do have a master's degree in education, but I don't teach because I think the education system's a little wrecked right now. Hopefully they'll fix it. But I do enjoy teaching people. So if there's anything that you'd like to learn, I mean, I don't know everything, but I certainly, if you have any questions about these circuits, please put them in the comments and I'll try to answer them. So I'm going to be buying lumber here in a couple days. Now that my friends finished up with their Jeep, try to get things a little bit more organized in here and get all my toys in my toy box. I don't know, this place is really hard to work in right now. And I'll work on finishing up a couple small walls that you've basically already seen how they get framed up. So I'm gonna hurry and throw up a couple walls, and then I'm gonna put those beams on the top. And they're not gonna be very high. They're only gonna be, I think I'm gonna do 2x8s just because the span is gonna be very long. And I'm gonna also build them out of some plywood, and I'll show you how I'm gonna put those together. And then after that, I'm gonna span, I think it's gonna be 2x8s across, because I can't seem to find the #1 yellow pine. I don't know if anybody out there knows where you can buy that stuff. #1 yellow pine is like the best stuff. You can span quite a ways with it. Somehow nobody in my area has it. So that's what I'd like to use, but I think I'm just gonna have to go with a bigger #2 pine board, which I'm not thrilled about, but whatever. So look forward to those videos. If you enjoyed this video, like, share, and subscribe, and stay posted for when I actually wire this up. Should be in a couple weeks. Hopefully I'll get the beam video out and all these beams done next week, like I've been yammering on about for the past, I don't know, few weeks about getting that done. And after that, we'll hit up the electrical and get some real lights in here. So thanks for watching.